Hi everyone, it's Leslie here, and I have decided to do the popcorn problem for today's exercise in the Math AQ. And I decided to do this problem because as soon as I saw that it involved popcorn, I knew I had to do this problem because I think anytime that you bring in an element like popcorn, it's a signal to everyone that it's unintimidating. And it's a signal that we're here to explore and play together. And I think everybody just takes a sigh of relief and gives himself permission to have fun and learn. So I really wanted to do the popcorn problem. So here is my solution to the popcorn problem. So the popcorn problem is a problem that has students exploring volume by creating prisms, rectangular prisms, and filling those prisms with popcorn. And so what it asks you to do is take two identical sheets of paper, which I've done, and fold one vertically and one horizontally to make two prisms. So that's what I've done here, A and B. A is obviously folded vertically and B is folded horizontally. It then asks you to measure the dimensions of each prism, which I've done, the length, the width, and the height. And the students would obviously do that. And then it asks you to make a prediction about which prism will have greater volume. And I always like to convey over and over again with students that volume is the amount of space that a prism occupies, or something occupies. So, so how they have to predict which prism will have greater volume. And I know that when we manipulate the dimensions of a prism, we change its volume. And so my prediction is that B will have greater volume because B has a greater base area. However, I think that many of my students would predict that both prisms would have the same volume because both were created using identical two-dimensional shapes. And so I think that there's a lot of logic in that prediction. It's sort of an intuitive prediction. And I think that's why this exercise is good, because it gives students a real sense of the way that when we manipulate a prism's dimensions, we manipulate the amount of space it occupies or its volume. So let's get on with the experiment. So we're asked to place the vertical shape inside the horizontal shape and fill that shape with popcorn. And this is so fun. Oh, I'm spilling popcorn inside, but that's okay. So I'm just going to quickly fill this with popcorn. Plus it gave me an excuse to make popcorn, which is always fun. There we go, just about there. We are about, oh, sorry. This is going to take a minute. Okay, and I'm going to add a few more on top. I am going to grab the camera just to show it close up. Sorry, I don't have the best videography skills. There we go. So prism A is now full, and now I'm going to remove it from prism B and see if they do indeed have the same volume. And in fact, they do not have the same volume. And I know that because the popcorn, which filled prism A, does not fill prism B, which means that B takes up greater space. So the next thing that it asks you to do is to consider by how much would you have to reduce the height of prism B to make the volumes equal. And so I've done that here. And so I've done the math here, and I've done it algebraically. Depending on what level this lesson is being delivered to, they may or may not be able to do it algebraically, but I won't go over this in detail, but basically I knew that I had calculated that the volume using the formula length times width times height was 990 centimeters squared, and I used that, and I based that on my original chart, which set out the dimensions of both A and B. So I knew that the volume of A was 990 centimeters squared, and I had the length and the width of Prism B, 7.6 times 7.6, and so I determined that that was 57.76, and when I divided 990 by 57.76, that would give me the height, and so the height was 17.14 centimeters, which means that I would have to reduce the height of Prism B from 30.5 from 22.8 centimeters to 17.14 centimeters. And in fact, just for fun, I did that. I'm going to try and demonstrate. I think the easiest way to do that is to sort of go like this, kind of improvising here, but if I then pour the popcorn, making a mess, from Prism B into my new Prism C, which is the reduced height prism, and add in the popcorn that I've spilled, we can see that Prism C now has the same volume as Prism A. That is, it takes up the same amount of space as Prism A. So that's how I would solve that problem, and that's how I would work with that with the class. I absolutely love this problem. I think we would have so much fun working with it, and would certainly use this again. Thanks for watching.